All right, nice. I can see myself. How are you guys enjoying your Star Trek so far? Yeah, nice. So before I get started here, put on your hands 1 to 5. 1, you've heard of Bitcoin. 5, you deployed an app, or a dApp rather, sorry. 1 to 5, I see a lot of 2s, some 1s. This guy in the front has a 5. All right, maybe we can switch spots. So, why blockchain? Some of you may think it's just a buzzword and there's not really any business application. So why a conference talk? Well, if you're like me, your friends and family know that you do something that you spend 40 hours a week sitting in front of a computer. So you may have received texts like this one. And there's a lot of reason for this, right? Back in late November, early December, we saw the price of Bitcoin absolutely skyrocket. As it approached $20,000, we heard that it may approach $40,000. We heard stories of guys with 10 Bitcoin from 5 years ago suddenly having hundreds of thousands of dollars. Everyone was buying it, mining it, or at least Googling it. This company, Long Island Iced Tea, changed their name to Long Blockchain, and their stock nearly tripled overnight just by putting blockchain in their name. The hype is there, but is the long-term value? So why me? The truth is I've never bought any cryptocurrency. I've never mined Bitcoin, and I haven't deployed any dApps publicly. However, in preparation for this talk, I did spend more than 100 hours researching Bitcoin and blockchain, and I did put a node on the Ethereum blockchain, and I deployed a dApp to a private instance of the blockchain. My goal today is to get that 100 hours down into 1 hour that's hopefully more useful to you than if you were to sit at home and Google what is blockchain for an hour. So a little bit about me. I work for a consulting company called HMB. I've been with them for about 3 years. What I really enjoy is the breadth of smart people that we have. We have a ton of people that are experts in a lot of different areas. And we have clients across wide sectors, and so every project that we're presented with gives us a bit of a unique challenge, which is engaging and keeps you on your toes, and it's a lot of fun. I've also been married for about 3 years, and in preparation for this talk, I asked my wife for a fun fact. I was looking for something quirky, something that might engage you guys a little bit, and she said, "You have the best wife ever." And I think, sensing the hesitancy in my voice, she said, "What, is that not fun enough?" And I said, "No, it's a blast." So blast fact, I have the best wife ever. Before we keep going, has anybody here invested in Bitcoin or any other cryptocurrency? All right, so about half it looks like. So a quick disclaimer, I am not endorsing Bitcoin or any other cryptocurrency as an investment strategy. For me right now, we still see the price fluctuating with every news article that's released, and Andreas Antonopoulos, who's one of the leading Bitcoin advocates, thinks that Bitcoin still has 3 to 4 boom and bust cycles left in it, and so right now is not for me. If you're one of those that just raised your hand and want to try to convince me after this talk why it's a good idea, feel free to go ahead. So remember my graph from the first slide with Bitcoin's price in late November, early December? It would mirror this Gartner graph almost identically. It's a surprising curve, but it's nothing new, which is why Gartner came up with a name for it that they call their hype cycle for emerging technologies. Now, this is from July 2017, but you can see that Bitcoin and blockchain is coming off of the peak of inflated expectation almost into what's called the trough of disillusionment. Laying this over the Bitcoin graph of price over the last year or so, it would mirror this almost identically, which is why I want to follow this graph through my talk today. So I'm going to lead you up the innovation trigger by describing how Bitcoin, or blockchain rather, works and the benefits of it, which is going to take us to the peak of inflated expectations where I describe all the industries that blockchain is affecting. I'm going to guide you through the trough of disillusionment by telling you about the negatives of Bitcoin and or blockchain rather, sorry, and all the bad use cases for it. I'm then going to guide you up through the slope of enlightenment by telling you the good use cases for blockchain and showing you a short demo of how approachable programming on blockchain really can be. I'll leave you at the plateau of productivity, which is where you leave this room and you start playing around with blockchain for yourself. So before we get started, a couple of quick assumptions that we need to lay out. One is that we all know what a cryptographic hash function is. Now, if you don't, no worries at all. All you need to know about them is that it will take input of any size and give you a fixed size output. You also need to know that these cryptographic hash functions must perform efficiently, and for even the slightest difference in the input, it has to give a significantly different output. The second assumption is that Bitcoin isn't the same as blockchain. Saying that Bitcoin is the same as blockchain is like saying React is JavaScript. React isn't JavaScript. React is one implementation of JavaScript. So saying that Bitcoin is blockchain is severely limiting the potential that blockchain could have in every other industry outside of the payments industry. So I think when I talk about blockchain, a lot of you guys probably think about that image on the last screen, right, with the gold coin and a lot of money, people making money overnight, essentially. I certainly did up until about 6 months ago. I went on a trip with a buddy, and he doesn't work in the payments industry, and he was telling me that his company was starting to look into solutions using blockchain. And when he told me that, I thought, wow, that's really interesting because I really thought it was just for cryptocurrencies. So after that trip, I started looking into everything that it could be used for, and I was pretty surprised. I started reading a lot about the medical industry and the electronic medical record space, or what's known as EMR. I have 3 people that I'm pretty close to that are in the medical industry. One is my mom, who works as a nurse. The second is my brother, who's in med school at Ohio State currently. And the third is one of my buddies who's in med school at Vanderbilt. So all 3 of them, as I was learning about this and reading about this, got excited about the potential impact that blockchain could have in this EMR space. I was talking to that buddy that goes to Vanderbilt in the late winter, and he was telling me that he spends 1 to 2 hours a day on the phone with other doctors' offices just trying to get the patient's medical data that they're going to see that day. When I thought about how much he was paying in tuition, just over $53,000, I thought to myself, those are some pretty expensive phone calls you're making. And so we see that right now, as of 2016, there was one stat that estimated that the EMR space was roughly $28 billion. If blockchain could even affect this industry by just a little bit, it would be a significant disruption technology. So what is blockchain? Potentially the worst description I heard is by a guy named Don Tapscott, who's a co-founder of the Blockchain Research Institute. I saw an interview with him where he said, the way I like to think of it, blockchain is like a chicken McNugget. And if you wanted to hack it, it'd be like trying to put a chicken McNugget back into a chicken. That analogy did absolutely nothing for me in describing what blockchain was. So instead, I found this other short description that was a little more useful, which is blockchain is a persistent, transparent, public, append-only ledger. This is nothing novel, as it's probably the first thing you'll find if you Google what is blockchain or a conglomeration of the first couple links. However, it does a really good job of succinctly describing what blockchain is. Another easy way you can think about it that a lot of us are familiar with is it's like a spreadsheet where each row has a reference to the previous row. Now, as I proceed through this talk, you'll see what I mean by a reference to the previous row, and you'll see how blockchain kind of started to get its name. So if you've searched on YouTube what is blockchain, you might have seen one of the hundreds of videos of people stacking different sized boxes, one on top of each other, or slipping sheets of paper into them and moving them around. Once again, another analogy and example that didn't make much sense to me. So I tried to come up with my own example here. It all starts in the top left with that guy at the computer screen. If you think about my EMR example, this could be the doctor in the doctor's office at the end of the day inputting patient notes or diagnoses into his computer. All of that data comes into a transaction pool and sits awaiting to be picked up by a block. Once it's picked up by a block, it's distributed out to the nodes in the network where some consensus work happens. Now that consensus work box is intentionally black because for me, this was the toughest part to understand how blockchain was working. But once that consensus work happens and that consensus work finds a valid nonce and a valid hash, it then passes it to all the other nodes in the network who agree or disagree that that is a valid solution that that node just found. If they agree that it's a valid solution, That block is then added to the top of that node's blockchain and then communicated to each of the neighboring nodes of that node. That process then repeats until every node in the network has a copy of that block as its latest block in its blockchain. So I said consensus work was confusing, and you guys might have thought I glossed over it pretty quickly, but I want to dive into that a bit deeper now. When you sit and look at code for 40 hours a week, sometimes the best way to describe something is in pseudocode. So I thought hopefully this would appeal to a room of technologists, and hopefully this pseudocode makes a little bit of sense. But essentially the goal of the node in consensus work is that it's just guessing a nonce value until a valid hash is found. Now this nonce value guessing happens randomly because, as I mentioned at the beginning, for any input that slightly varies, the output from a cryptographic hash function is going to be significantly different and unrelated. So there is no way that this node can more intelligently guess a nonce than by randomly guessing some number. Once it picks a nonce, it then takes all the transactions in the block, the previous block's hash, which is key in how that chain starts to get formed in blockchain, and generates a hash value from that. Now in our example today, we're going to say that a valid hash is a hash that starts with 4 leading zeros. This could change depending on what implementation of blockchain you're looking at. But as I said today, we're just going to say that 4 leading zeros is a valid hash. So once it finds a valid hash, or a hash that starts with 4 leading zeros, then it jumps out of that while loop, and it would validate the block. In this block validation is when that block sends the node, or the node sends the block to all the other nodes in the network to be verified if we've found a correct nonce value or not. They validate this by taking in the same inputs that the original node took in and seeing if the hash that they generate from that produces a hash that starts with 4 leading zeros. Does anybody know what this, maybe the more common term for this consensus work is? That's more, yeah, you in the second row? So proof of work is the algorithm that's being used. Any other guesses? Yeah. Yeah, it's mining. So a lot of you are probably familiar with mining. And some people know that what's going on here is consensus work. So what's actually happening when you're mining? A lot of people know that you're somehow mysteriously making money, but essentially what you're doing is renting out your CPU power to solve this consensus work algorithm. So you're working on the consensus algorithm in that network, and right now, for both the Bitcoin and Ethereum implementation, as this gentleman in the second row stated, it's called the proof of work algorithm. Now these consensus algorithms must be hard to solve and easy to validate. They have to be hard to solve so that no one bad actor can more repeatedly solve for nonces more than any other actor in the network. They have to be easy to validate so that once one node finds a valid solution and passes it off, we're not waiting for that compute time to happen all over again and all that random guessing to happen. So it's easy to solve or easy to validate because you can, once you have those inputs, you can easily generate the hash efficiently and find out if that hash meets our criteria. So right now, as I mentioned, Bitcoin and Ethereum are both currently using what's called the proof of work algorithm. The problem with this algorithm is that it wastes a lot of energy. Every node in the network that isn't the one that finds that nonce wastes all that compute power and time that it's spent just trying to guess the random nonce. And second of all, Joe Schmo sitting at home, for example, me with this MacBook Pro, could not get on and solve for that nonce because there's people with certain hardware rigs that are much more efficient and going to be able to essentially mine or make a lot more guesses at what that nonce is a lot more efficiently than I am. There's an alternative that's surfaced that's really big in the Ethereum community, and the Ethereum guys are actually probably going to implement it within a few months here, and that's known as the proof of stake algorithm. What happens in proof of stake is that if you want to join the pool of potential nodes to mine, you put down a down payment, and then the task to validate nodes and transactions is random, or blocks and transactions is randomly assigned amongst the nodes in that pool. If you do so correctly, you're rewarded with cryptocurrency. If you do so incorrectly, that down payment that you put down is taken from you and you're kicked out of the pool and can never participate in it again. If consensus algorithms sound like something interesting to you, there's a lot more out there. If you search consensus algorithms on Google, one of the first few links that pops up will be a Wikipedia article that has 7 or 8 different consensus algorithms. If you're interested in this, I would encourage you to read it. So how does this all work? Well, at its base level, blockchain is made up of transactions. It's essentially just a large group of transactions, and so today I want to take the bottoms-up approach in describing exactly how blockchain works. So transactions are huge, but essentially they just represent a change of state. If we think about my medical record personally, my medical record from the time I was born has just been appended to. Now, in reality, that doesn't happen because I've moved around, I've seen different doctors, and there's no one doctor that has everything that I've ever been diagnosed with. However, if you were to be able to get the whole picture of my medical record, you would be able to see, as I grew up, how my medical history changed. These transactions just transfer an asset from one cryptographic identity to another. Now, as I already mentioned, they're propagated through the network using a peer-to-peer protocol, and that happens once they're included in blocks. So what are blocks? Blocks differ depending on what implementation of blockchain you're looking at, but essentially they're just a collection of transactions, and no matter what implementation of blockchain you're looking at, they're all going to have at least 4 values in common. That is a collection of transactions. How many transactions is on each block will differ, once again, depending on implementation. It will contain the hash of the previous block, and it will also contain a nonce, and then once it's solved, it will contain its own hash. Let's see an example of this. So here, the nonce is 72608, and there's no data in the block, and we have a valid hash that starts with 4 leading zeros. You'll see that as I type in the data field, even the smallest change makes a significant difference in the hash. So each time that data changes, this block needs to be remined to find a valid hash. The nonce is now 16524. And so you could see that as every input that I made, every letter that I added changed that hash. So hopefully this is starting to bring some light to what I'm talking about. So what is a blockchain? A blockchain is just a series of these blocks stacked on top of each other, and it all starts with the genesis block, which is frequently created by whoever starts that implementation of blockchain. They manually add it when that implementation is started. Each node in the network contains a full copy of the entire blockchain. So let's go back to the videos. In this example, I have a blockchain that has 5 different blocks in it, and you'll see that each block contains the previous block's hash in it. If I change the data in block number 1, it makes every block thereafter invalid because it changes those hashes all the way down the line. Now what you're seeing is a powerful principle of immutability that is one of the strongest security assets of blockchain. In order to change data further down the line, you would need to go back in time and be able to remine every block that's in that blockchain after whichever block you wanted to change. Now, I've already mentioned it a little bit, but these blocks and blockchains sit on nodes, and a node is essentially just a computer with a copy of a blockchain. Nodes are competitively cooperative, and what I mean by that is when they first start working on this consensus algorithm, they're all competing to find the correct nonce. Once one node suggests a solution with the correct nonce, they all turn and start being cooperative with one another to validate if that nonce is indeed a correct solution. It's a really interesting study on game theory, the way these nodes interact with each other. And then each network, or a network is just a network of all the nodes, which is pretty self-explanatory. So how does a new node join the network? Well, somebody with a computer can just download a client, and then that node will start looking for neighboring nodes. As it's looking for neighboring nodes, it's recursively building a tree of what the current view of the network looks like. Once it builds out that list, it starts receiving the full blockchain from the other nodes in the network. Once it receives the blockchain, it starts validating every single transaction that's happened in that blockchain thus far. Now, this validation of every transaction for all of history is essential because it ensures that this new node didn't just receive a copy of the blockchain from one bad actor and then take that as truth. So every node validating the entire blockchain gives us a lot more trust in the network. So how do these pieces all work together? What are the benefits, right? What's the benefit of these nodes guessing random numbers? Yeah, do you have a question?
Yeah, I know you tried separating out blockchain from Bitcoin or Ethereum and so on and so forth. Can blockchain actually be prevalent without cryptocurrency? Or would anyone actually run all these different machines without actually getting paid for it?
Yeah. So the question for everybody in other rooms is, can blockchain exist outside of cryptocurrency? Like, would anybody run these without being paid for it? And the answer is yes. However, being tied to a crypto, each implementation of the blockchain that you see will have some sort of reward for the miners in that system, or else there would be no reason for people to volunteer their compute power for that. Does that make sense? So the question is, does the fluctuation in prices of Bitcoin drastically affect the prevalence of blockchain? That depends. Right now, early on, I would say yes. As we see different implementations of the blockchain happening, and especially like private implementations, I wouldn't say that is as strongly tied. So what are the benefits? Satoshi Nakamoto in their original white paper in October 2008 outlined two significant benefits for Bitcoin specifically, but could be used for any instance of the blockchain. So I'll dive into those now. The first is taking out the middleman, and on the left there, you see that line that Satoshi Nakamoto had in his paper about cryptocurrencies and how taking out the middleman works in that. And that's pretty self-explanatory. However, if we get back to the EMR system, what I want to convince you of is putting the EMR system on the blockchain would also take out the middleman. The hospital that my mom works at has two different EMR systems on two different floors of the hospital. Of that 28 billion that I mentioned earlier in the EMR space, a significant amount of that is spent annually just on mapping this data from one form that one EMR system understands to another form that can be consumed by another EMR system. Now, if both of these EMR systems are pointing at the blockchain, we're all interacting with data in the same form, and instead of having to hit a third-party API, these can talk directly to one another. The second is the double spend problem. And for this, I want to jump back into the finance example because it's really easy to understand in the finance world. If two of you guys were really impressed with my talk after this, you would ask me for a copy of the slides, and that would be no problem for me to go home and send an email to two people at the same time with my slides as an attachment. Both of you guys would receive that attachment and be happy because you could open up the slides on your own machine and they would work fine and dandy. However, with a $1 bill, this doesn't exactly work the same way. I can't send one copy of the same dollar bill to two different people. The first guy that gets it is going to be really happy. The second guy that gets it is going to be really mad because that dollar's not actually going to exist. The way that blockchain prevents this is by validating every single transaction. If I tried to send the same dollar on blockchain, the first time it went through, it would say it's valid because it sees that I own that dollar. The second time that it went through, it would see that I no longer own that dollar and invalidate the transaction. So this second person would never get it. Now, there's a lot of other benefits that blockchain brings around security, especially in the EMR space. The first is that it's decentralized. As I previously mentioned, every node in the network has an entire copy of the blockchain on it. This is a huge benefit for disaster recovery plans and for preventing attacks by hackers. They would have to take out more than just one node to take down the blockchain. In fact, if one node was taken out, it would simply just go down for however long it's being attacked, and then when it's back, it would just go through that process I showed of joining the network as a new node does. Second is the immutability. I showed this in the blockchain video where if I changed the data earlier on in the blockchain, it invalidated every single block thereafter. In order to perform some sort of attack and change the data that was previously on the blockchain, it would take one bad actor acquiring 51% of the total CPU power on that network. Now, as the network grows, you could see that this becomes more of an insurmountable task. In late March, to perform a 51% attack, the cost was estimated at over $7.6 billion. Third is that blockchain takes advantage of cryptography. Now, I'm not going to dive into how blockchain takes advantage of cryptography, other than to say that it utilizes asymmetric cryptography. The best real-world example that I could come up with is that if there are any football fans in the building, then I know you guys have seen people hold up random signs like the one in the top right corner. Now, us on TV sitting at home, we know what a bridge, a tree, a Superman logo, and a Batman logo mean, which is likened to this football team's public key, right? The public key on the blockchain is a series of numbers and letters, and we all know what numbers and letters are and can recognize those. However, without having the private key, which in the football instance is the knowledge that the team inside the huddle has that they gained from practice that week, we have no idea what this picture actually means in this scenario, and it seems really out of place and jumbled to hold up a Batman logo in the middle of a football game. The last is the social impact. Now, this doesn't relate huge into the medical industry. However, it is worth noting that there's currently 2 billion adults without formal financial services in the world, mainly in third world countries. With blockchain, instead of having to wait for brick and mortar infrastructure to be built around the areas that they're at, they could quickly have access to benefits such as insurance, bank accounts, and loans with just access to the internet. So what industries is blockchain affecting? Well, here's a list right here. A big one is Barclays. They're a huge company, obviously, but you'll see some other companies on here that are startups. There's actually a decent amount of companies right here in Columbus that are experimenting with blockchain. There's one company that's trying to put the human genome on the blockchain that can then be used in research studies, which I thought was really interesting. Now, you may say, hey, Brett, well, I don't work at a startup, so we don't have the speed and flexibility to suddenly go to a blockchain solution. And you might say, I don't work for a company as large as Barclays. So what do I do with blockchain? Well, there's a couple of real-world examples of companies that are in that mid to potentially large size that I wanted to highlight for you guys to show you what's actually going on with blockchain with some companies that you may be familiar with. The first is Kodak. Kodak is building a platform called Kodak One that will allow photographers and artists to manage the digital rights to their photography and pictures online. So instead of having somebody come to your website and copy and paste a picture and use it without having the correct rights, they'll be able to manage and see when people are actually using their photos. The second is Walmart. In partnership with IBM, Walmart implemented a blockchain solution that helped them to track their beef products across China. This solution helped them reduce the time it took them to track beef products from weeks to minutes. Why is this significant? Well, in a world where farm to table and organic is all the hype at restaurants and grocery stores, being able to track your food from its source is a big advantage for these grocery stores and restaurants. They could also track things such as what temperature was the food stored at throughout its life process of getting to the grocery store, and things like that. The last is LL Bean. LL Bean is working to embed IoT devices in some of their outerwear to track when and where their clothes are being worn and how often they're being washed, and they're going to transmit that data back to the blockchain. Now, if anybody here knows anybody that works in IT for LL Bean, I would love for you to get me in contact with them because I reached out to them to see exactly why they're using blockchain for this, and I didn't hear anything back, but I'm not convinced that they need blockchain for this. I think they could just use a more traditional back end. So So why not? I showed you that blockchain is affecting a lot of different industries, and I gave you a lot of security benefits for why a blockchain solution is solid. Why wouldn't you implement it? We'll move from the peak of inflated expectations all the way down into that valley and the trough of disillusionment now. So the key negatives. There are a lot of technical barriers. First, it takes time. It takes time for developers to understand what's really going on here, and it takes time for the technology to be developed into a full-blown product where it can be used for different scenarios. The second is that there's a significant lack of resources. If you get online and search what is blockchain, you're going to find a lot of regurgitated articles over and over, and not a lot of unique, in-depth technical content. There's also a lack of resources when it comes to developers. There's not a lot of people that have experience programming on the blockchain, and so if you put a minimum requirement of like, hey, I need developers with 2 years experience, you're going to significantly limit your talent pool for the people that you're looking at. The second is key management. Everybody that's interacting with the blockchain has a private key locally. If this private key is somehow confiscated or stolen, whoever steals that all of a sudden has access and control of every asset that has previously been attributed to that private key. And there's no way that we can take back that control. The second is the risk of losing the private key. If that hard drive were to crash or get disrupted, there's no way that we could get access to those assets back. This is what you heard a lot of people say, like, oh, I have 10 Bitcoin on a hard drive somewhere at home that I can't really access because I don't know where it is. If you don't know where the hard drive is, you don't have the private key, you have no way to access those assets. And last is scalability. In the medical example, I found a research study that the CDC estimated that every American adult had roughly 3.1 doctor's appointments per person. If we multiply this out, it adds up to about 1 billion doctor's appointments just in the US. If we think about each doctor sitting at their computer inputting data for 1 billion doctor's appointments, that's a lot more transactions than right now any instance of blockchain can handle. Right now, Bitcoin's implementation is handling about 7 transactions per second, and Visa processes about 500 times that. So you could see that there's some growing that needs to happen if blockchain solutions are really going to go full scale like that. And last is the node hardware space. I told you guys that every node in the network has an entire copy of the blockchain on it locally. Right now, the Bitcoin instance of blockchain is over 150 gigabytes. As this continues to grow, we're going to severely limit the number of people that can potentially participate in that network just because of restrictions on hardware space. There's not a lot of people that are sitting around with 150 gigs plus free on their hardware or hard drive that they're willing to give over to blockchain implementation. So when would you use blockchain? You've counted the costs and you know the goods and the bads, but you still want to forge ahead. But as you can see, we're not quite to the bottom, so I have to start with the bad use cases. The first bad use case is your company's intranet. This is a bad use case because your company probably owns that data from front to back, and it's never leaving your organization. There's no need for you to interact with another company based on that data. The second is a to-do list app. I said that blockchain and transactions give you a good view of what the state looks like over time. But when's the last time you wanted to see what your to-do list looked like 6 months ago? As long as you got those things done, you've probably moved on in life and don't really care what was on your to-do list then. And the last is Snapchat. Snapchat, to my knowledge, isn't currently using blockchain, but I would argue that they should almost never use blockchain because the way Snapchat started was to be a picture sharing service where your pictures were deleted as soon as the other person saw them. If they used a blockchain solution for this, those pictures would live forever. So blockchain and Snapchat doesn't form a really good marriage. What is a good use case? In my opinion, there's 2 times that it would be optimal to use blockchain. The first is when you want to track entities over time. The reason this is a good use case is because blockchain solution is fully auditable. Imagine you worked at a large company and you brought in one of the big four accounting firms, and you could show them, hey, here is every single transaction that we've had over the last year. I would imagine that this would make the accounting company's job very easy to do and very quick. The second is if you want a full picture through time. So I already mentioned my medical record. It would be highly beneficial for some doctor 10 years in the future to be able to see what I was diagnosed with today, to make a better, more informed decision of regarding my medical information. Last is that it removes overhead. Now, there should be an asterisk next to this because it does remove overhead in one sense. And what I meant when I put this bullet up is that right now our current solution for tracking entities over time is often to put a modified by and a modified date field on every table in our database. Without having to add those two fields to every table with blockchain, you can see the entire entity and how it started and how it ended after every alteration. This gives us a lot more insight and information than just when that entity was edited, as that often doesn't show us what was edited, it just shows us that it indeed was edited. The second good scenario is for sharing data across organizations. Putting these solutions on the blockchain allows you to inherently trust the data because you can trust that every transaction and every block has been independently validated. This allows you to know that when you get the data, it's in a safe, true set. The second is it gives you a full picture through time. You no longer have to guess what a third-party company is doing with your data behind the scenes, and you can see exactly what the data looked like when it came into that third party, and then what they did to it, and what it looks like once you're beginning to interact with it. There's no guesswork or black box that's going on between other companies that you're interacting with. And the last is that it eliminates cost. This is another one that should have an asterisk next to it, because it does eliminate costs in the sense that it prevents all that time and money that's spent from mapping data to one form to another. However, it does cost money, to store data on the blockchain. But how? How would you do this? Say you saw that and you saw the companies and industries that blockchain is starting to have an impact in. How does this make sense? How do all those companies that are doing that use blockchain transactions to do that? Well, the short answer is they don't. And this is where smart contracts and decentralized apps come in. This is where the Ethereum instance of the blockchain really shines. They do this stuff really well. Essentially, smart contracts just exchange things of value in a secure and transparent way. So it acts like a server that's living out on the blockchain and allows you to interact with it and call functions from it. These smart contracts can either be called manually by users, or they can be set up to autonomously execute when certain contractual obligations are met. So some pros and cons of smart contracts. One is with this autonomy, we are eliminating the human factor, and so we have an increase in speed and we have an increase in accuracy. Additionally, we get all the benefits of the blockchain that I showed earlier around security with immutability and stuff like that. The cons are that the physical products that we interact with on a day-to-day aren't super ready for this smart contract implementation. When I gave the Walmart example, most likely the beef products that they were interacting with were individually tagged with IoT sensors. A lot of the stuff that we interact with on a day-to-day aren't tagged with those same IoT sensors, and so the stuff we interact with just isn't quite there yet. Secondly, it's hard to determine the responsibility in a court of law as to if this smart contract executed something that was controversial. Would it be the person that executed the smart contract that was liable, or would it be the person that published the smart contract, or would it be anybody that has a node in that network that's hosting the smart contract? It gets pretty fuzzy. And last is that the code lives forever. If you publish a bug with your smart contract, it's out there. You're not getting rid of it. You can make it so that the code isn't executable, but people could go back in time and see that bug in the code, and you're not going to be able to get rid of it. So a quick demo here at the Slope of Enlightenment. I wanted to give you guys kind of what I was talking about when it came to that EMR solution. I wanted to show you what I imagine that kind of looking like. And what I imagine that kind of looking like is a decentralized app that I'm about to show you. I wanted to show you a couple of tools that I used along the way and how approachable writing smart contracts really is if you want to get started. So the first tool that I used is called Truffle, and Truffle is just an NPM package, so any JavaScript developer is going to be really familiar with NPM, and you can just go and download that. What Truffle gives you is these pre-built boxes, or essentially just modern web apps that come ready to integrate and work with the Ethereum instance of the blockchain. From the same people of Truffle comes what's called Ganache, which gives you a local private instance of the Ethereum blockchain. Ganache also gives you 10 local accounts to use and play around with locally. And so it makes it really easy to test out smart contracts before you actually are playing around with real money and deploying it to the Ethereum instance. And the last is a Chrome and Firefox plugin called MetaMask. What MetaMask does is it allows you to manage identity when you're interacting with the Ethereum instance of the blockchain online. You can go ahead and download this without deploying any dApps or working with any dApps. Anybody with Chrome or Firefox can download MetaMask and start to interact with the Ethereum instance of the blockchain. So that's a bit of a tongue-twisting sentence. So this is what the code looks like. This is just the app.js file, so this is nothing new. I'm only showing this to show you that it looks like nothing different than what most developers are familiar with interacting with. We just have an app.js file that looks like any other project. This is the smart contract itself. This is written in a programming language called Solidity, but I wanted to put it on display to show you guys, anybody that works with Java, C# or JavaScript, this is going to look pretty familiar to. Right? We have this idea of a contract, which is essentially just a C# class, and it has the idea of inheritance. So it's inheriting a contract called the killable contract, which allows you to kill decentralized apps and smart contracts that are on the blockchain currently and allow them to not be called again. And then we have some private fields, we have some modifier functions, and we have a constructor function down there at the bottom. This function is one that I'm going to show being interacted with in the demo that I'm about to show. It's really simple. I just wanted to show you guys that this is super approachable. And so it's called the give doctor access function, and it has an only patient modifier, which is essentially like an authentication attribute in C#. And so each call that comes into this smart contract is going to have what's called the sender property. And so it's going to have the public key for whoever called that. So this only patient is going to check and make sure that whoever's calling this function is the original patient that this medical record belongs to. If it indeed is, we're going to add the doctor that the patient's trying to add to their list of doctors. And if it's not, we're just going to kick the user out and not do this function. So here's the demo. Off to the right, you'll see Ganache client running locally and the 10 different accounts that it gives you. And off to the left, I'm running Truffle compile. What this is doing is just compiling that smart contract that I just showed you down into bytecode that the blockchain can understand. I'm now running Truffle migrate, which is deploying that bytecode out onto the blockchain. So if you watch on the right side, sorry, it's really small, but where that 0 is, once this executes, you'll see that number go up to 6. And that's showing us that the smart contract is now on the blockchain. Now on the left-hand side, I'm running npm run dev, which is just an npm command to run the app, which any JavaScript developer is familiar with. And we're going to pull up the browser. So I'm logging in as the patient in the MetaMask plugin up here in the top right corner. And behind that, what you're seeing is what I imagine the patient's dashboard looking like. You would have some blood pressure, some BMI, some cholesterol. So we're logged in as the patient, and we're going to go ahead and try to add a doctor. So we're going to add doctor first, and I'm going to pull this public key off of this and add it as my doctor. So MetaMask is popping up and asking us to confirm this transaction, and I go ahead and submit it. Now there is a way to get this to post back, but I didn't want to take the time. Once we see that circle, we know that this has been deployed to the blockchain and the transaction has been validated. So now when we refresh, we see that this patient now has doctor first as a valid doctor. So if we log out and log in as doctor first, we can now interact with this patient's medical record. So we're going to go down and type in the medical notes field and add a medical note to this patient. And it's just going to be called first note. And once again, MetaMask pops up and asks us to confirm this transaction. Once that circle appears in the top right corner, we know that the transaction has been confirmed on the blockchain. And so now we know if we refresh, that medical note should appear as the patient's first medical note. Now, this is where you'll see that modifier function come in handy. This doctor first is going to go in and try to add his friend doctor second. And since he's not the original patient, this transaction is not going to be validated. So we go in and we try to submit the transaction, and we get denied. So I know that's a really simple example, and you could do that with any language and have an authentication filter set up where certain people can't do things on certain screens, right? That problem was solved long ago, but I wanted to show you guys this demo just to show exactly how approachable this is for every developer in the room, and to kind of give some sight to what I imagine this looking like sometime in the future. So what's next? There's a lot of different routes you can go from here, and it depends on exactly what you want to do. If you want to learn more, I found the Software Engineering Daily podcast extremely helpful. They did a month of blockchain in the month of March, and they had a lot of helpful interviews and in-depth technical interviews with a lot of leaders in this space. If you want to code, you can fork the Bitcoin code and start your own implementation of Bitcoin. Or if you go to ethereum.org/token, it will show you how to start your own blockchain implementation with your own cryptocurrency. If you want to do more research, there's a lot of research going on in this area, a lot of really interesting stuff around consensus algorithms, increasing throughput, game theory, and economics. Blockchain is opening up a new world of study in the economics world because for the first time ever, economics can analyze this in real time. Last is if you're investigating this for your company, I would encourage you to look at the Hyperledger Suite or Corda, or email me, brett@brettkoenig.com, and I would love to chat more. So in conclusion, as we've seen, the value of Bitcoin and other cryptocurrencies will continue to boom and bust in cycles, and determining their future value is very difficult. However, we are already seeing the sustained value of blockchain technology in multiple different industries. So this is where I leave you right here at the beginning of the plateau of productivity, and I would encourage you to go out and start trying to program on the blockchain. So here's some resources and sources, and that's all I got. So thank you very much. If there are any questions, you can either ask them now or feel free to come up to me afterwards.
I have questions.
Yeah. Yeah, if you talk about external company relationships, it's really going to depend on your implementation. But you can essentially stop the code from being able to be executed. But the code will be out there, but it can no longer be executed, is what I was trying to say. Does that make sense?
Yeah, so you can turn it off. It will live, but you don't act on it.
Exactly. Yep. Yeah.
How is this data stored? So there's blocks of the chain itself on your
It's just stored on your hard drive. Yeah. Oh, yeah. That's something I don't know a ton about, but I'm sure you could find it pretty quickly if you search it. Yeah. I know they use the same thing that Git uses.